So in the moderated mode, now what the hell does that mean?
Oh, must check to the moderate. So I still can't find the.
I needed can I?
I still can't find the slides. Where's slides? Oh, share slides. I see.
Okay, so share screen, I have that. Okay.
Oh,
Share
I can share.
slides.
Do you want to share?
No, you do. You do. All good.
Okay.
Yeah, good. Looks good. Oh, yeah, all professional stuff. Look at this. Is Greg online? No, I don't even see him. So you just have been pronounced co-chair because my co-chair is bombing off.
Let me share. Right. No.
Okay, we're feeling like starting slowly. Good evening. All right. So since my esteemed co-chair is bumming off and didn't even dial in, we have a new co-chair. Now, immediate promotion, and the chairs have proven yes, highly competent. Right, figuring out the tool that changed completely again. Every time better, every time different. Um, Yes, welcome to IETF 121 BIER session. We have a pretty light agenda, so let's push it down the hill. So what's the status? The usual note well. I won't bore you with details. You know, it's getting more and more every time. Next one. So nobody harasses anybody here, please. All right. Too fast. What was still there? You know, sometimes it's useful to read that. Let's bump it back. So, okay, background harassment. Okay, I think main thing, nobody's getting harassed. Then that's how you use the Meet Echo. Everybody, please come in so we get an even bigger room for even more people. All right. And now, agenda, you know where these things are. Everybody's a professional here. Good. So status, we have some overlay, especially around the PIM stuff by Human, and then we have some new stuff by Trollus. Now, who's taking minutes? Nobody looks at me. Nobody lost. Gentlemen, we need a minute taker. Otherwise, we're not official. Nothing counts. No minutes taker. Okay. So I'll be damned. Here I go. So I'll be taking minutes. It's your own fault if I utterly misrepresent. Except I have to sign in. Oh, this tool is just hysterical. Okay, I have to figure out the tool later. So let's go through the status quickly. Next. All right, so BIER EVPN made it out the printing press. Congratulations, took forever. Yep, one of the most useful documents when it comes to the BIER as far as it's deployed today. Next one. All right, so the BIER tether has been gracefully recovered by the AD into the tracker. All right, so AD review is done, and there is some active discussion going with Les on the IGP side. Which, sorry, I'm wearing this stuff, but you know, otherwise I get blinded. Yeah. So that's ongoing, and I think lots of the last suggestions make sense. That's being wound down. Then the BIER IDR extensions are waiting for AD and under review, and I saw that the GenArt still has some pending unresolved comments. So whoever's in charge, please attend to that. The PHP is in the ADQ, is also under review from the directorates, but I didn't see anything particular popping up there. The OSPF v3 is our troublesome child. There is comments from AD hanging since April. Others have been poked multiple times. They didn't address it. So Huaymo, I don't see him here. Okay, probably hiding under the chair. So that stuff has not been addressed. The BIER FRR is still on some AD comments from August. I didn't look at the specific comments, but it looks like they have been addressed. Next one. All right. The non-MPLS extensions expired, so that needs refresh, please. Okay. And the question is, do we need some kind of early reviews on the stuff, or should we push it on the AD? That's a question in the room. Should we push it towards the, it doesn't belong into the MPLS working group, and nobody will have really an opinion on it. We could show it to IGP, but then coding are kind of, whatever we're adding there as information is very similar to the MPLS stuff. So I don't think there's much to be done there. I'm looking for opinions because otherwise it's kind of ready. So if no working group, no early directorate reviews, then I probably just go and push it out towards ADQ. The BGPLS extensions, okay, they have been hanging in the working group last call for a bit, okay. LSR has been asked for comments, nothing was provided, okay. Same question, do we need some early directorate reviews or should we push it on the AD? I mean, we're pushing on 80, then we'll get the review anyway. But if we get some early reviews, the 80 will have less work, right? Yeah, should.
From LSR or from IDR?
Sorry. So LSR got the stuff pushed. I don't remember the BGP guys, the IDR guy got anything pushed. I know we pushed it on the LSR.
It's BGP LS.
Yeah.
Both of IDR working group and LSR working group are reviewed, has done the review. Yeah.
But nothing came back, correct?
Yep.
Nothing.
No
Okay.
comments.
Yeah. So no
received
comments from both
IDR
groups.
and LSR. Yeah.
Comment?
Go ahead.
I mean, in the end, it's better if people in the working group try to figure out the usual suspects who, if explicitly pinged to provide feedback, would do a good job. And then if you either tell those names to the AD or try to figure out how to get them through directorate or so. But I mean, we need names to approach and not just randomly hoping for working group.
Well, it's not random. I mean, we're pushing the stuff on the official working group mailing list. They're supposed to read the stuff.
Yeah, but even in a working group, right, there are typically just a few people or so you should know as being able to provide useful feedback.
So you think we should corner individuals?
Yes.
And execute them with extreme prejudice? Okay.
They're figure out some carrots, right? I mean, maybe they have something for review in return. I don't know.
Carrots. I used to have little stars and unicorns and nothing. IETF is failing me. All right. So good suggestion. So that pertains to the LSBR X. Okay.
Just one quick comment, So I just got a message that the Meet Echo thing went into observer mode, so probably somebody pushed the wrong button somewhere, somehow.
Sorry, what? I lost you, Gunther.
Yeah, so in Meet Echo, I have like this observer mode thing. It's like a new state of dealing with it. I'm going to ask for it to be switched back. So observer mode is sort of like saying like you can only broadcast and nobody can actually say anything or like stream or whatever. It changed now back again. Yeah. I was just letting you know.
So the switch room mode to moderated. All right, I switch it to moderated. Hell, I know what that means. Okay. So that's what you want? Switch mode to free? Hell, when you're training on this tool every time we come here. All right, thanks. So what were we? So LS BIER extent, individual. So less on the IGP, who will be on the IDR that cares most? The usual Jeff Haas, poor guy. Okay, well, I'll poke them as, you know, personal favors, of which I have few. All right, then BFD is actually, so Jeff, I think, shot something back that has been addressed, but we need to shepherd right up. So opportunity to, you know, for fame and riches, whoever wants to shepherd the stuff.
Human is a shepherd, but he
Human's
didn't,
already assigned?
upload his
Yeah,
comment.
there is no other
No.
guy that is called Human in the room. You don't have to
Actually,
look, you know, around.
I saw that and I checked. Currently, it's Donald who is,
Correct. Donald is actually as the shepherd. Yeah,
yes.
not Human.
Oh.
Donald.
yes,
Donald.
so you're off the hook.
Yeah.
Sorry.
But I save you for later. I save you for later. You're not off the hook completely.
Okay, so I
So,
basically I
yes,
follow up with
Donald is, again, at least at some time, he agreed to be a shepherd. So probably ask him, and if he has any questions, I will react to his review promptly.
Okay, good. Next one. Yeah, so I know that, you know, I'm getting you here a good hiding. I actually went and look at all the stuff where we are, okay? So the BIER ping, so there is routing director, there's a comment outstanding that has not been addressed.
Really?
Yeah,
I need to double check.
That's
Okay,
what the tracker
I'll take it
says.
on. I'll take it on.
They're unhappy. You have to,
They're
you know,
not happy. Okay.
give them chocolate to push the right
I
button.
will.
Yeah, okay.
I will take care of it. Let's go next.
The path MTU discovery doesn't have a shepherd review.
Oh, who is the shepherd?
Steve,
Stick hiding under the chair. Oh no, look, he has a big smile. I'm not saying needs to be done in 15 minutes, but I'm just saying where we are. Okay. BROM requirements also need shepherd, and the SecDeer had some unaddressed comments. BIER in 6, though, so we have the last call done. That stuff seems to be wrapped up. The question, should it go to 6-man before we pester the AD with it? I think it should. No consent? Okay, so I push it on 6-man. I mean, should we also get it like early directory review on int area or something? No opinions? No, I want to protect the poor AD who is already queued from here to, you know, to Antarctica. No, we should deliver, you know, pretty reasonable stuff to rubber stamp rather than, you know, ADs being pestered with, like, you know, running loops until we deliver something that bears muster. Okay, so BIER in 6 goes to 6-man. And early reviews, I think I throw it like a SecDeer and probably int area, if they even have a directory, I don't know. I think they do. All right, so int area, sec, and it goes to 6-man. 6-man, int area, and SecDeer. All right, and then the prefix redistribute is waiting for shepherd write down.
shepherd is five more train.
Y mode, I don't know who is the shepherd. I didn't look at the shepherds. I just saw that there is no write down, so the stuff cannot progress. All right. Next, I think that's it. Yeah, and I think that's it. So that's the status. You know what you have to do, right? Oh, yeah, sorry. Excuse my secretary. You know, we are, you know, we are training her in the finer points of alcoholic beverages. Okay, so I think we can move to presentation. So Human was, you know, on the PIM signaling stuff. Can you share, please?
All right. So first, I felt bad I thought it was only my 2 drafts, and I'm keeping everybody from drinking. Then I noticed that there is another 20 minutes after mine, so then I don't feel so bad. Okay, so the PIM signaling. Next slide, please. I'm not gonna go through so much of this. I think we gone through lots of this stuff. So just to give you a little bit background, refresh everybody memory, why we tried to do this originally, and for the LDP, MLDP signaling over BIER as well. So there were some interest with some of the tier 1 operators, service operators out there with BIER. They wanted to put together like a clean network core, IGP underlay, BGP overlay, and they didn't want to use any of the legacy protocols like MLDP, point-to-multipoint RSVPTE to build that core because they wanted just to keep it, signaling IGP. So they were kind of talking to us saying that, well, when it comes to the access routers, typically the ones that are sitting at the tower at the cell sites, those are like older routers, and they don't support BIER since it's hardware specific. And they were kind of asking us that how we can make BIER work in the core, not us in specifically the working group, how to make BIER work in a core while having PIM or LDP on the access. How can we stitch it? So one of the things is obviously having multi-segment. If you are doing inter-AS type of solutions or inter-area type of solution, you can have a multi-segment. You have a segment in the core that is BIER, and somehow on the other end of the segment, you have MLDP or PIM. I don't know if anybody supports BIER to MLDP or PIM inter-AS or inter-area solutions. The other thing that kind of came up was that, well, why not just kind of tunnel some of these legacy protocols through the BIER core? And this is how these ideas for the PIM signaling over BIER and MLDP signaling over BIER kind of were born. So that's the real background. We tried to make it a little bit politically correct here, but just so you understand what the background was. Next slide, please. Yeah, again, complicated diagram, but basically what it is you have the receiver. The receiver says, I want to join the SG. When it gets to the BIER boundary, we look at the source, and we need to figure out what is the BIER router sitting on the other side, closest to the source. In the draft, there's a bunch of ways to figure out what these BIER edge routers are that are closer to the source. And we kind of grab that SG and signal it via back then PIM type of signaling. But now we have PIM Lite, which was kind of designed for this type of applications. We signal the join SG or the prune SG from one BIER edge router to the other. The BIER edge routers, they keep track of all the incoming SGs and what tunnels, BIER tunnels, edge routers they need to have to go, and you build this state, and the multicast starts working on it. Next slide, please. So again, what happened was that we did the last call. There was a good, we were very close to make this a RFC. There was a very good comment that, hey, this PIM, I shouldn't say PIM, this join and prune signaling that you guys are doing in this draft might be useful in other places, which I think there's a couple of cases that, usefulness of it. So we kind of decided to bring out this signaling out and build, give birth to PIM Lite, and then try to incorporate the PIM Lite back into this draft, which is what we kind of did. Next slide, please. So with this specific draft, I will incorporate the PIM Lite into it. the solution should not change at all because like PIM Lite is exactly what we were discussing in this draft. We just yanked it out. But I just wanted to make sure that, you know, if there are any comments, any concerns, we kind of bring it up right now so I can put it into the draft as I start changing the draft to incorporate the PIM Lite. That's the entire purpose of this presentation, just to refresh everybody's memory and see what the concerns and comments are. Uh-oh.
And I'm just trying to understand what you mean with incorporate. Referencing, right?
Yeah, you're right.
Not pulling the text back in, right? So that's
Well,
It's-
honestly, I haven't looked at it,
Mhm.
but somehow I'm gonna say that, look, for signaling of the joins and the prunes,
Mhm.
we are using PIM Lite,
yes,
and go look at that draft, how it,
exactly. Yeah,
yeah.
yeah. That's so referencing PIM Lite is. Then I wouldn't have stood up and asked the question.
Yeah, my apologies. Is my I blame it on the French Canadians. They changed my English.
So will that basically become an application of PIM Lite, or is it still some stuff that is BIER specific in the whole thing? The discovery of the stuff, right, on the edges,
Yes.
is still BIER specific. Okay.
Wow, you got good memories. Yeah, we had to figure out the edge routers, how we discover it, and those are specific. Yeah.
So yeah, I'm also trying just to remember.
Yeah,
the
that's
PIM
why I
Lite-
brought it
PIM
up.
Lite discussion. So it seemed as if these RPF or these vector thingies to signal the bits. Um, I was kind of concerned that that was unnecessarily complex. That the traditional model in BIER, I thought, was that the ingress PE would know about the bit assignments of the egress of the BFER from the IGP.
Yeah.
I think we expect that to be the case.
Yeah.
And so then it wasn't clear to me why it would need more in the PIM join than just the same address that's used in the IGP, right? Why would it need still the bits? That seems like duplicate information. Now we have the potential conflict. So the BFIR looks at, oh, wait a second, I think this egress router from the IGP has the following bit assignment, but this join says it has a different bit assignment. So
Let's don't forget, we don't precondition IGP being present. If the whole thing is controller programmed, you cannot rely on IGP.
that's fine, but then I
identifiers.
think we should make that kind of different system setup options, right? If we have an IGP, I think there should just be one single source of truth. If we don't have an IGP, completely agreed. But if we do use an IGP, then I think we wouldn't use that particular extension in PIM Lite.
No, okay. So just to be clear, the part that you were correct is we need to build the bits on the BIER router that is closest to the source, right? Because the source will send the traffic,
Yes.
will get to the BIER edge router,
Yes.
and that BIER edge router needs to have the bits to send it to the other side
Yes.
that eventually gets converted back to PIM and goes to the receiver.
Yeah, but
How do you build the bits?
Okay, so the current text says that the ingress, the BFIR learns the bit assignment of the BFER from the new bit stuff in PIM Lite. The BIER
The
specific
joins
information.
that are coming
Yes.
in for the specific SG.
And I'm saying I think we only need to have this if we don't have another way for the BFR to learn it. So if you already are bought into distributing this information through the IGP, then we don't need to duplicate the effort in the PIM Lite vector.
So, sorry, maybe I'm missing. Distributing what in IGP? The SGs?
The mapping between the address of the BFER and the bit assignment.
But okay, but you need to somehow understand what are the edge routers that you're going to. You need to see
Yeah, but
which
you get that
receiver.
you do the PIM Lite join,
Yeah.
but it is a simply a unicast PIM join without the need for the additional RPF vector information about.
Sorry, for the benefit of the people that are remote, name an association, although it's all the usual suspects.
Okay, this is Stig. So I'll just try to answer that. So what is in this join attribute is a BIER ID of the BIER router that sent the join. So it's not the bit positions. It's just the BIER ID. You have the BIER ID in the BIER header too that when you are sending. But if you do the decaps to get the PIM join, you lose kind of that information. So we wanted to have it present in the part as part of the PIM message itself.
On the mic, please, because otherwise it's hard to follow. We have a lot of remote people.
Yeah, but exactly the same information is coming from the IGP if you use the BIER IGP extensions.
You need to know the BIER ID and the set ID to find the bit position from the IGP, right?
That is all in the IGP extensions as well. So I mean, we just have two different options, and the point is, I think we should make it clear that there are two options, and not expecting that you duplicate the information.
Jeffrey?
I think there are three aspects here, all entangled together. One is that the need for additional signaling, and not only well, we can argue whether we need to signal the BFR ID, but at least we need to signal the subdomain ID. So we need that additional signaling already. Because we want to say that I'm sending this PIM join through this particular subdomain versus another subdomain. That's one thing. So we need that additional signaling. Whether we need to signal the BFR ID of the egress BIER router, that can be discussed. But I know that when the BIER MAPN was specified, initially we did not signal the egress BFR ID, but we added it, I think, at least for one reason was for the convenience. We can say that we will not do that for PM case, or we can say that we will do the same thing. That's one thing. The other one is the need for the PIM light is really just the reason for the need for the PIM light was that initially we said we will just use PIM signaling, but it turns out the PIM signaling requires the adjacency, the neighborship. And here we are not doing that. So we said, okay, we'll do PIM lights that get rid of that problem. And that's the second. And then finally, how to find the ingress router. That is an independent problem, and it's the same problem that we solved for the MLDP in-band signaling and Rosen MAPN or even BGP MAPN. It's all the same problem. So that's separate. So I just wanted to mention those three things. Yeah.
That's fine, and I'm not talking about the getting rid of the hello relationship. I'm just saying that we have all the necessary signaling in the IGP when we use an IGP, right? I mean, we can take it to the list, but please tell me what you think is missing. I don't think there is something missing if the IGP is used, and if we think there are real business cases where there is no IGP running at all, it's perfectly fine to have the PIM light extension, but otherwise we would have duplicated. If there is BIER extension in the IGP and we have them in the joins, I think that's duplicate.
Just one quick add on to that. We need to tell which subdomain we are using. So that needs to be signaled.
That's in the join attribute, the subdomain.
So how the heck would this work if we don't do PIM light, but the normal BGP signaling? That they would have had to solve the same problem.
Okay, so look, there's many ways to skin the cat, right? Yeah. And one of the things was that the way that we started thinking about this is just let's use what's already available to them. They are like, they understand PIM joins and prunes. So
no, I'm not saying go away from PIM. I'm saying that I'm not aware that the BGP signaling needs to signal the subdomains to work. So that information must be available from the IGP as well, from the BIER extensions of the IGP.
Maybe we need to take this offline because honestly, I'm getting lost. So there were a couple of things. Number one, again, just for everybody to understand, is we needed to track all the BIER edge routers that are closer to the host that want to join a specific SG. Mm-hmm. So how to track that since the join was coming based on a specific SG,
Mhm.
we said, let's just send that signaling information
Mhm.
through the same packet type, which is a join, rather than coming up with something new, to the BIER edge router that is closest to the source. So
And
that way I build a state.
but we have this, the IGP signaling is mapping the relevant overlay signaling address, which is your IPv6 loopback address or whatever it is,
Uh-huh.
right, to the BIER.
But how do I
information.
put that?
We can take it offline.
Yeah, but architecturally, you don't have an IGP. You cannot make the assumption. Okay, it's not about today's customer needs. The whole architecture does not mandate IGP underneath. Okay,
It's-
and then building a special case up to the authors, whether they want go down this way, right? And with EVPN, as far as you remember, it was when you start to build software and you have to cut through so many layers to get this information. It's far more convenient if the stuff is already in the signaling when you process it. I'm not advocating either way, but I think that's the gist of the discussion.
I-
Okay.
As I said, I'm not saying to remove it completely from the draft. All I'm saying is that I would like to see the option mention that this the attributes are not needed when the same information is available from the IGP.
But your case, again, I'm not trying to go back and forth, but I want to understand in your case, if it's MVPN on the BIER edge routers, I understand what you are saying. But if I'm trying to stitch PIM
Mm.
between two PIM domains, I'm not getting it.
Same thing. We can let's take it
Sure.
offline in detail. But actually, I wanted to go back to the original question, right? Because we do have all these BGP solutions, and they have been very painful for us who started out with Draft Rosen and everything, right? That you build networks with PIM because everybody has to understand PIM anyhow. So how for the customers you worked with, they come around and now ask for PIM again instead of BGP?
Well, I mean, we implemented this. I'm not trying to push this because there's an implementation,
Mhm.
but it worked just correctly. What they did was that,
Yeah, we also had Draft Rosen implemented for 10 years in Cisco, and then
yes,
Juniper
but
people came along
that's a
and said,
that's still a pain in my butt because I want to go to NG VPN, and then their operators are saying no, it's safe with Draft Rosen. So
no, but
it is
that's
what they like, right? I mean, so you cannot argue with. So
no,
here's a solution that they like.
but I'm
Folks,
surprised
we're
that-
not here to, write Inventor's Dilemma as another book. All right. So stick.
was just
Is there something you want to throw in? Otherwise, take it to the list, including all the banter.
Right, stick here. Okay, so at least the way I see it is if you already have PIM, have deployed PIM, and you have like islands of PIM, right, that you want to interconnect with BIER,
Yeah.
then this is quite natural because you
Yeah.
already have the PIM signaling. It's very simple to implement.
Yeah.
But when it comes to this, I'm not sure if we should talk more about it, but at least you have the subdomain and the BFR ID in the BIER header. So you have everything you need without the join attributes. That's correct. The only thing is when you do the decap, you need some way for PIM to know what this information was. And if you don't have it in join attribute, you would need to do some other trick when you decap to give this to PIM.
And by the way, I love the idea to use PIM instead of BGP, right? I was just wondering about the customers, how they come to now prefer PIM over.
Not for us to judge, for us to write,
Oh no, but I like to
the
understand
bills
the
after we
customers'
build the stuff. All right. And then fix things again. All right.
Well, if customers have the argument it's simpler, I'd love to hear that, right? So that's all.
They love it. I don't know. Anyway. next
Okay, to the list, the authors take that and run as they want with it. Interesting observation by Stick that actually when you take the BIER frame, you're already on the encaps, you can figure the stuff out. All right.
Okay, so, oh, that's the wrong title. I think it's more than 00, but anyway, next slide, please. So again, same idea here. Let's go to the next slide. I'm not going to give the background. It's exactly the same as PIM. So with this one, we wanted to stitch multiple MLDP islands together via BIER. And with this one, we use TLDP RFC 7060. And basically, the TLDP kind of bridges that FEC from the ingress B router to the egress B router to build that state of figuring out the edge routers that are closer to the host, the BIER edge routers that are closer to the host. How we find the B router that is closest to the source, the same mechanism as PIM signaling. Next slide, please. So with this one of the things that we changed was that when this happens, for the BIER router that is closest to the source, we changed the BIER header protocol to be MPLS, just to signal it on the other end that there is an MPLS payload following. So that was one of the main changes. I don't think there was anything else, just the fact that we were using the TLDP. Next slide, please. So the solution was done. We did the last call. The last call was done. I think I think we were gonna assign the shepherd, and we didn't assign it. I don't know what happened to it, and eventually it died for 2 years after the last call. So kind of just trying to revive it.
All right. So last call done, you basically want to revive it and basically push on the process. All right.
So
Name association, please.
Greg Mirsky, if Erickson, if you looking for shepherd, I will volunteer.
Done deal. And I forgot what I need to do, but we'll do it after.
Bribe him properly.
I have a list.
Oh, you have a list. Okay. Wow. All right. Thank you. I got myself in a trap, but that's fine.
Okay, thanks. Now we're scaling up BRTE. Hold on to your seats.
Well, hopefully this is actually going to be a lot less complex than the last few presentations I had on more further looking solutions. So what's the origin story of this? So I think one origin story from Michael Ment and his team is that somehow they figured out they want to work on something else than just BIER, and looked into MPLS and traffic engineering. So if you've been following that work there, you saw that they're doing a lot of unicast stuff. And then at some point in time, they figured out we can actually bring these things together, BIER and the MPLS traffic engineering work that they've been looking into. And we get to the next slide. So from my view, this is really about formalizing what we've been doing a little bit of hand waving about in BIER-TE section 536, which was kind of the architectural overview answer on how do I make BIER-TE work in large networks, because we do know that the bit strings are a limitation for the scale, what you can do with a single packet, more so than in BIER. We obviously didn't have the space to formalize that all well in the BIER-TE RFC, and this is effectively what it's doing. So the idea is you use a unicast TE tunnel from a BFIR over to some egress domain that actually is small enough that you can surface with a single bit string, right? So ingress replication, and then on the egress side, let's say in a particular in a city, on an egress city, you're doing the BIER-TE. And so that is based also on the typical large wide area network bandwidth designs, that most replications are happening on the receiver side edge, and that the amount of ingress replication that you need to partition up the network into different receiver edge domains is well applicable. And then, of course, on top of that, we obviously want to use BIER-TE primarily also for highly resilient services. So we had to look into all the necessary aspects to make FRR work across that solution. And so that goes into 3 parts, and we're seeing that. And so this whole stuff is also described in more detail in a research draft, early stages. So we're just giving high-level overview, but the idea, I think, would be this is really nothing new in the forwarding plane, but it would be a description of exactly all the details in the forwarding plane and how to build this out. So I think it would make a great, standards RFC on one particular way to design and do forwarding for large-scale networks with BIER-TE and unicast TE tunnels on the ingress side. Next slide. So, okay, I think You know, everybody here is fairly, you know, expert, so I think we can go fairly fast over that. So,
Don't rush. We have time.
okay. Um, so yeah, so the scalability of BIER and subset, right? We have the SI, we're breaking apart the receivers in a BIER domain into different subsets, each of the size of up to how many bits do we have? Let's say we have what is it? 1024 bits. So we're breaking it up in partitions of 1024. That's the bit string, and it almost doesn't matter how you split it up because you're not concerned about the topology in the middle. And in BIER-TE, it's a little bit more difficult because you do need to be considering about the intermediate hops. Next slide. So here is kind of the comparison picture, right? With BIER, you're only concerned about the BFER. And let's say one bit string is the blue one, and only BFER3 and 2 are in that bit string. BFER1 is in another bit string. It, at the high level, doesn't matter very much how you allocate the bits. We have done more detailed analysis that that's not entirely true, but in comparison to BIER-TE, that's correct. And then if we go into BIER-TE, we're assigning bits not only to the BFERs, but also as shown to the links in the topology. And that, of course, reduces the number of BFER we can assign to every particular bit string that we have. We need to reserve bits for the topology in the middle. And how do we do that in general, right? So the BIER architecture RFC just gives very high level guidance, and this document is meant to be a lot more specific and establish a particular design paradigm there. Next slide. Right, so a subtopology, so to speak, for BIER-TE consists of the BFER and links together. The total number of bits have not to exceed the bit string size you have in the network. So let's say, you know, 256. Now we're also saying that for the constraints of this solution that we're building here, that this actually is a single well-connected subtopology, right? So you're not, I mean, there are other ways on how you could do it. They're all a lot more complex and less easily to understand. This is the easy to understand one, right? So you're taking one subtopology, all the links, all the BFER together, forming one part of the of the topology that you are putting into one bit string, right? So and now you're partitioning the network up into the substring. Each subtopologies, each gets a different SI. Now, beside the single connectivity, if we want to be able to also correctly for the whole solution make FRR work, what we need to make sure is that each subtopology by itself is also so-called two-connected, meaning that subtopology itself needs to be able to be still connected between all the nodes if any single link fails or any single node fails, right? So it needs to be the most simple redundancy by itself. If we don't have that requirement in the design in the way that the controller creates, for example, these subtopologies, then we will have a much more complex solution. Next slide. So here then is the simple flow on how this works, right? So we have a red and a green subtopology that we're interested in, each with a set of BFER and a set of intermediate nodes. The ingress BFIR on the left-hand side, whenever it wants to send packets to one or more receivers in one such subset topology, is putting that into a traffic engineered unicast. Let's say we specify TE as the mandatory support, then you can still decide what technology you want to use for SRTE tunnels. It puts that in the tunnel and sends that to the first router in that subset. We call that the SBFIR, so the subset BFIR. So that's the routers labeled as A for subset A and subset B, right? And there, the TE tunnel encapsulation gets removed, and thereon it happily goes out as a BIER-TE packet being traffic engineered within that subtopology. So very simple, right? So now, yeah, so the requirements against the tunneling protocol, yeah, thank you. So the interesting part, of course, is what failures to support full FRR, full resilience do we have, right? So there is obviously the first case, which is there is a failure within the unicast tunnel. So we use any of the supported unicast FRR mechanisms, right? So just IPLFA or TI FRR, so all the ones that we understand, nothing special there. Of course, when we kind of start to think standardizing on this, we may want to raise certain expectations like must support this and this FRR that we think is a good minimum requirement. If there is a failure on the within the BIER-TE subdomain, equally, we have proposed drafts for that on how to do that. So the real crucial new aspect here, by connecting a unicast ingress tunnel with an egress BIER-TE domain, is what happens if the ingress BFIR of the BIER domain fails, right? So that's what this picture shows. You have the red crossed out subset BFIR. Now that's failing. What you need to do? Well, you need to actually do something on the unicast tunnel side that redirects the traffic into a backup tunnel that doesn't go back to the unicast tunnel, but that actually goes back to a second BFIR in the BIER-TE domain, right? So that's kind of a change of determination of backup tunnel exit point, right? So that's the new procedure for the controller to calculate what the best possible backup SBFR is. Then, of course, there is the added interesting detail, which we don't have that much text here at this point in time. But when a packet arrives in the BIER-TE domain in a different router, that doesn't necessarily mean that the bit string needs to be exactly the same as if it arrives at the different router, right? So the point of local repair at the point in time when it is doing the encapsulation into the backup tunnel to the SBFR, that may also need to do another AND and OR operation against the bit string so that it does work when the packet enters the BIER-TE domain in another SBFR. Next slide. So here then the protection within the BIER-TE domain, that again is showing the two drafts that had been started to be done about that. So that is really nothing new here, just integrating BIER-TE FRR into the solution. Of course, also still an open point to be done. And yeah, just showing that in this case we have one node failure on the a link failure in the top picture that typically is easy to overcome, and then a node failure that typically may require the typical you send multiple copies to the next hop. So next slide. So this again goes as a reminder through the different modes of operation. So we've got the BFR on the left-hand side. The big green one is the TE traffic tunnel that goes all the way to the subset BFR, the ingress router to the domain. From there on, the small green path are just the normal BIER-TE paths that had been calculated by the controller. So very simple. Next slide. Now, unicast, standard unicast failure within the unicast part. We just imply whatever TE mechanism we like. LFA, what is it? TI, LFA, all these, not via. There are many of them. Maybe we want to have an opinion about what the minimum simple one is for this type of solution. Still goes back, no change on the BIER-TE side. Next slide. Opposite side, we have a failure of a link purely within the BIER-TE subdomain. Same thing, we need to apply, independent of this integration solution, some appropriate BIER-TE FRR solution, which would also round around that by, you see the link, same principle as in unicast, right? You detect point of local repair, you detect the error, you're modifying the bit string to go around. Next slide. And so this, of course, is then the hard case. The SBFR fails. So on the unicast side, that one where the big red arrow starts, that is the point of local repair. That basically now creates an encapsulation that sends the packet to the router on the bottom left, which is the backup SBFR. There, the things get decapsulated, gets forwarded to the necessary next hop of the SBFR, right? So specifying all these things is ultimately the scope of kind of what we propose as a standardized solution to make, BRTE work in scalable environments, large networks, with one-to-one protection. Next slide. Yep, so what's the status of this? So all the main components of the concept have been validated through P4 Tofino hardware implementation. So BFR, PLR, SBFR, BRTE, FR. So all the components are known to work even on our reference for the worst possible high-speed hardware switch, if that's the right way to phrase it. There is a report on that. Actually works quite well, even without recirculation, so at good performance at that. And then the recirculation within the BRTE side can actually be optimized in the same way as that was shown in one of the prior IETF meetings for BIER itself. So yeah, as I said, right, I think this would make good sense as a follow-on there. I think there is no fundamental new implementation work. It's mostly about stitching the features together to show how to build the solution. And then, of course, given how this is touching things like the SR side, the PIM side, and kind of an operation solution thing, even there's obviously going to be some question where to put it in the IETF, BIER, PIM for the SR side, or MBOND. But in the end, right there needs to be some interest.
Tony P. Juniper. So did you give any consideration how you would actually partition the network into these subsets so you are within this, well, let's say 1024 bits? That's a very interesting problem because everybody has to agree on that stuff. So either you somehow centrally signal it or you have some very clever distributed algorithms that agrees on the stuff. And if the topology changes, your partitioning may go to hell in a handbasket.
So the TE world, I think, works, whether it's unicast or multicast, works best if you have a central good magician.
Okay.
We have tried to do distributed magic once, which is with the Live, the dual path unicast redundancy. Aliyah and others were doing it, and it was terrible complex. It was brilliant, but when we then asked the folks, the mathematicians, they said the results that you can get are not as good as with a centralized controller. So I would start with the centralized controller, and if there are enough people that feel like Aliyah and others on the unicast side, hey, we want a distributed solution, I say all the power to you. Good luck.
So just to tickle researchers, one of the few proven actually distributed algorithms is something called maximum independent set, right? So could be a good starting point. Hey, researchers, right? Hey, ambitions, please. Yeah, okay.
I'm very happy that I have some researchers that actually do, write code for actual high-speed forwarding as opposed to a lot of math only. So,
David Lamperter. Sorry if this is a stupid question. I'm not super into BIER. These bits that we're just talking about that identify the links, they are already set while the traffic is unicast tunneled, right? It's added at the very ingress at the beginning.
Yes.
Okay, thank you.
It's just at the point in time when the packet needs to be rerouted at the edge, then you may need to change them, but there are basically design paradigms by which this could be done with a simple take away some of the bits, some of the links. I don't need to send the packet over anymore, and add some new bits, new links where it does have to be sent now.
Thank you.
Gunter speaking as just a contributor here. It's more like a clarifying question, actually I have two of them. So often I see when you have like a big topology and you want to prune links from it, they use like administrative groups. Is that something what is used here?
Okay, now we're in the, I'm in the opposite role. I can only give stupid answers because I didn't understand the question.
Oh, why was not speaking
The
clear?
administrative group, sorry, I did.
Sorry, yeah. So like, when you have like a bigger topology with like thousands of links,
Mhm.
then often, what you do in IGPs
Mhm.
is, if you want to prune links from a topology, you use like, you attach like a number to a link or a color or whatever.
Oh.
That is often called like an administrative group or an extended administrative group. And actually, that is a tool what you have, in your ability also to use instead of actually using these bits. So that's the first question. Second clarification question actually is like links have two sides. You can go in this side or you can go in that side.
Mhm.
So if you have like one number,
Mhm.
it assumes the traffic has to go like in. You don't have a site to send the traffic into,
Mhm.
basically. So
Yeah. So I think the first thing I remember from RSVPTE and the IGP extensions for that, and at that point in time, this maximum subset was called two people with a lot of coffee manually doing this, right? So I'm not aware of how far they have come to do that partitioning of the network, in a PCE. But to the extent that it exists, obviously this can exactly be applied here. It can even be applied to BIER to optimize that. So yeah, the partitioning as a controller thing, as Tony said, is a great tool to have automated if you want to do this type of large scale
But to
engineering.
chime in, I think, Gunther, are you going towards like shared risk link groups, SRLGs, this
for
kind of stuff?
example, that's another way. Yeah,
Yes,
that's
and that is used very often, right, when you deal with TE networks, that people basically set the stuff as
Yeah.
shared risk, and they would expect this thing maybe
Yeah.
possibly to be in the same subset, right, for proper protection. Because once you start to split that stuff,
Yeah, because there are tools out there already which do exist to identify links.
yeah.
Well, what we did starting early with video multicast was to use the TE things for red and green subtopologies, even different directions on the same ring, so that you could do live with multicast, right? So yeah, so there's a lot of history on all of that. Your second point
Second
was
one is if you go to to one of the first slides here, you have like your topology, you have like the links, you identify them with numbers like 1, 2,
Oh yeah,
3,
yeah.
4, and
I
so
wanted to
onwards.
answer to that. So RFC 9262 has descriptions about all these things that you can do to save actually bit assignments, right? And one of the typical saving thing is that in almost all of the case, so you start out by saying every adjacency is a different bit. And in that case, going in this direction is one bit, going in the other direction is a different bit. And then you go and optimize so that you stuff as many, actual topology elements into as few as possible bits. And a bunch of these mechanisms are described, kind of what can a controller do to be efficient on bits. And one of that is to use the same number for a point-to-point link. And that works in almost all of the cases. And so corner cases are also, that's already controller mechanisms in 9262. Okay. Yeah, so this is very early, so just wanted to give, and if you all come out of the room and say, hey, we want this, then I'll give you a beer or something. No,
So no further asks. Okay. Queue's empty. Agenda done. Any other fears, uncertainties, desires? Yeah, no. Except all less. All right, thanks. So that was the session. I left the minutes. Everything was pretty sparse and non-controversial today. See you next time. Thanks. Goodie. So I better fire that off. What are we time was? Very good.
So if you will terminate the session, we can continue.
Sure.
You can do through. Nice.
The red, the exit bus. Here we go. Perfect. Thanks.
I think the recording is stopped. The recording of the session has been stopped.
Yeah, I think it's all done. I think we're good. So wait. So let me look at my agenda quickly because now it starts to gel. Because you wanted to have lunch, right, or something?
Hi.
Just more private. I looked at OEM requirements. I believe said their requirements been addressed and they confirmed to be addressed several versions away. So Human agreed to take as a shepherd on
OEM.
requirements.
Oh.
Yes, yeah, that's actually, that was our trade-off.
Oh,
So we played a little bit performance here. You know, we are theatrical. So verify with him that he is fine with that, and you can CC me on that.
Okay, I can change the shifter.
Yeah, but just make
Oh,
sure,
and
you know,
requirements.
don't requirements, don't drop on him like surprise. But
And it seems like he is another draft
yes,
shifter, right?
yes, Human. Shepherding, and yeah, so if anything that but I couldn't find any routing directory comments on BIER ping. I looked at the data tracker, there is none. Okay,
BIER ping or something else. BIER ping.
Lunch tomorrow?
Which?
12:30.
Here. Here. BIER ping, right? And then you can see some reviews from here.
Okay, I'll
Yeah.
look it up. Okay, then I'm missing something.
Mhm.
Okay,
Yeah.
yeah, but I'll look at the data tracker because if it's already been addressed, I will just make sure. Okay, I'm missing something.
All right, so good. So tomorrow. Great.